Hey guys, so I'm back with another video, this time for a slightly different case of the linear second order non-homogeneous equation. So in this case, on the right hand side, we have this general form here. So when we have this general form here of this p of x times e to the kx, we're just going to take that polynomial. So e to the negative 3x times ax plus b. The reason we use ax plus b rather than a different polynomial function. So let's look at ax squared plus bx plus c. So the reason we don't use this is because it's a different order than the polynomial here. So this polynomial is just x. So we use a first order polynomial rather than a second order one. So let's just cross that out rather than trying to erase it. So now we have to begin the tedious process of taking this the derivative of this y particular. So a little refresher for those of you who maybe aren't sure. Let's just look at what the derivative of a chain-ruled product rule is. So if we're just taking the derivative of that is g prime of x times h of x. So the derivative of the first times the second plus the derivative of the second times the first. So that's a really easy way to remember product rule, and the long and short of it is once you apply that to the function I've shown you there, y prime of p is going to be equal to negative 3e to the negative 3x ax plus b plus a e to the negative 3x. So again, that's just a product rule. We've taken the derivative of the first function, which is e to the negative 3x. So that's negative 3e to the 3x times the second, ax plus b. Then we take the derivative of ax plus b, which is just a, and we multiply it by our initial e to the negative 3x. So that's how that that specific y particular derivative works out. And then the double derivative, I'm not going to do a little step-by-step just because it's kind of gross to look at, and I don't want to confuse you more than I have to. So as always, if you have any questions, throw them down in the comments. If you need a full solution, I'd be more than happy to provide that for you, especially if this is giving you trouble. Wolfram Alpha is also a good resource for that sort of thing. I highly recommend spending the couple dollars that the mobile app costs. It's definitely a lifesaver. So anyway, we've got our y prime and our y double prime here. So what we're going to be doing is just plugging those back into our initial equation. And that's going to get you something that looks like this. It's a little gross, but it's not the worst thing. It's not as bad as if you were dealing with a trigonometric function. It's just a little long and unwieldy. So once we have that, negative 9b e to the negative 3x. And I've put this in brackets just so you guys can verify that this term right here is the y prime. And I'm going to do the same thing for the y, so you can verify that that's actually equal to y double prime. And I'm going to do the same thing for y single prime here. So let's put that equation in. And I'm actually going to expand it as well. So it's going to be the expanded form of this function right here. So that's going to be equal to negative 3ax e to the negative 3x minus 3b e to the negative 3x plus a e to the negative 3x. So that's the y double prime taken care of. Y single prime, and then just the y. I'm going to write that on a new line. So even the y on its own, I've expanded because we're using the method of undetermined comparing coefficients. So we have to be able to compare these ax and b e to the 3x terms easily. So what that's going to work out to is that's going to give you, once you simplify everything here, and remember that this is going to be equal to 20x e to the negative 3x. So once you simplify everything there and collect like terms, we're going to look at the coefficients. So for the coefficient of a times e to the negative 3x, your coefficients when summed up are equal to -9. When we look at ax e to the negative 3x, we get 20. For b e to the negative 3x, we also get, we get -20. So you can verify yourself once you add everything up here that these are how those coefficients work out. Now what we're going to do is we're going to compare to this right hand side. And what I'm going to do first is I'm going to pick this term to start with because there's no other b's, and that I know basically this function, this ax e to the negative 3x, has to equal 20x e to the negative 3x. So from there we can get that ax e to the negative 3x is equal to 20x e to the negative 3x. A is equal to 1. So that's how we figure that out. And then let's take a look at b. So we know that a here, a is equal to 1, so e negative 3x. Let's just cross that out right there. So when we get here, we know that -9 a e negative 3x, that should be plus 20, minus plus 20 e to the b 3x. Sorry about that. I'll go over all this in a second. Is equal to 0, because again there's no terms that don't have that x on there. So basically that means that b a is equal to 1 and b is equal to 9 by 20. So again, we're just comparing the coefficient of 9, the coefficient of b, and we know that those need to equal to 0. So that's how you solve for the particular equation. Whoops daisies. And let's just write the y particular out. So y p is equal to e to the negative 3x x, because that's just our a, plus 9 by 20. So that's it for this video. I hope you guys were able to learn something from that. And again, like I said, if you're not sure about anything I've done in this or any other videos, send me a private message or drop me a comment, and I'll do my best to answer your question, maybe even send you a full solution. As always, guys, thank you very much, and I'll see you on the